purpose of the scenarios feature is it allows testers to design a custom set of CWMP RPCs and requests to verify and operate on individual parameters in TR-069. In addition to CDRouter's existing TR-069 tests, which I'm going to bring up lots of different tests for verifying TR-069 functionality, as well as many different profiles tests. Each of these profiles tests contains a way to verify individual parameters within a given profile. And there's a set of tests for each of these profiles that will request the profile's name or request the profile's value, attempt to change the value. And all of this is done in a thorough but sort of generic. It's not very parameter specific. For example, one of these tests will get all of the parameter values for a specific, for all of the parameters within the profile, just to verify that they are actually contained in the profile and returned by the device. But there isn't any specific range checking or attempt to ensure that the value of the parameter is consistent with, is correct for that parameter or is consistent with its definition. While this provides adequate test coverage for verifying the data model integrity, if you want to perform some additional tests for individual parameters that you have in mind and want to verify that the actual value returned by the device is what you expect it to be, we now have CWMP scenario tests, and those can be found under the TR-069 section here, right here at the bottom. And it consists of one test which will execute all of the scenarios that the user has defined and identified in their configuration file, and I'll get into the details of that in a second here. So what is a scenario? A scenario is basically a text file that you define that lists a number of TR-069 CWMP RPC requests that you want the ACS in CDRouter to send. For example, you can list a get parameter value RPC for a specific set of parameters, and the ACS will retrieve those values, and then you can follow that with a set parameter values RPC for some of those parameters, and then perform another get parameter values request to ensure that the set parameter values you had just done was successful and that the value is indeed changed. I'm just going to go over the commands that are available in this feature. I mentioned get parameter names. This will issue a get parameter names RPC request for any of the named parameters. And then you can optionally verify whether the writable attribute is set to true or false for that attribute. You can perform a get parameters value for a list of parameters. And then optionally, you can verify that the value returned matches a specific value or that a value was indeed returned. You can perform a set parameters value and supply a new value that the ACS should set on the device under test. You can add objects, and you can supply an instance identifier, which is sort of like a variable used within your scenarios file. If the add object request is successful, the device is going to create a new object and automatically assign an instance value. And that instance value will be picked up by CDRouter and used in subsequent operations on any parameters created by that add object request. So and I'll show you an example of how that's used later on. And delete object does the same thing. You can delete an object that was previously created. And in addition, you can issue a reboot request to the device, and you can close and open the CWMP session. Without close and open, typically a scenario will go through. It will begin by starting a CWMP session with the device. It will issue all of the requests that you list in your scenarios file, and then it will close the session at the end. If you want to close and open the session in the middle of the scenario file, you can use these operations to do that. So here's an example of what a scenarios file will look like. But the scenario file, as I mentioned, is a text file. So you just open any editor that you're comfortable with and begin by giving the name of the scenario that you are beginning. So it starts with CWMP and then the name of your scenario. The name of our scenario is NTP settings, and it begins with a get parameter names RPC. And when that this will tell the ACS to perform a get parameter names request on this object, internet gateway device .time ending in a dot. So this will retrieve all of the parameters under this. It's possible to have multiple parameters lines in here, so you can request multiple parameters in the same RPC. Once the ACS has performed the get parameters names operation, it will store all of the results and then continue to the next line. Oh, this next level is part of the request. The next level is an indicator of whether the device should return all objects underneath the object or just all objects at the top level underneath that object, whether it's a full cascading retrieval of all objects underneath it or just the top ones. And then each of these writable lines verifies whether or not the return parameter name, whether the writable attribute within that parameter was set to true or false. So in this case, we're checking that the status value is false because that's not a writable parameter. Each of these NTP server parameters are writable, so they should be set to true. And the current local time is not settable, so that should be set to false. So CDRouter will verify that this is indeed the case, and will mark it'll mark a pass indicator for if that matches up, and if it doesn't, it'll mark a failure, and that will show up in the test results. And then we continue on. After the get parameters names from the previous page, we do a get parameters values for the same parameter, and then we verify some of the values. For instance, we verify that the first server is set to time.nist.gov. We verify that the second parameter does not have any value. And then we value that the current local time is returned. And it has a special token here with the square bracket, the word any, and closing square bracket. That token just verifies that will indicate in the log file that the parameter was returned by the device and that it did have a value, but the actual value is not verified in any way. If the device failed to return this parameter, then you would see a failure for this verification. Then we perform a set parameter values on the NTP server 1 parameter, and we change it from its previous value to pool.ntp.org. Then we do another get parameters values for that same parameter and verify that the device is returning the new value that we set. And this bracket here ends the get parameter values RPC, and then we end our session, or we end our scenario definition. Now in the scenarios file, you can define multiple scenarios. So the one I've just gone through is a single scenario. You can then define a second scenario below it, and so on and so forth. And you can have as many scenarios in the file as you want. And CDRouter's scenario test will run through each of those consecutively. So over here, we have a number of tests that we've run. I'll go over some of these results in a minute. Before we do that though, I'm going to quickly cover getting CDRouter set up to run this test. So if we go into our configuration section, we'll create a new configuration file. And in order to run any TR-069 tests, we need to have a minimum set of settings configured in our config file here. We need to make sure that our LAN interface matches the interface that we're going to be using for testing. So we'll set that to ETH1. Anything that's commented out will take on a default value if it has one, and that will be indicated in the help text over here on the right-hand side. So LAN interface defaults to ETH1, but if you're running your test interface on a different interface, then you'll want to change LAN interface to match that. So this is the interface attached to the LAN side of our device. Our device uses 192.168.1.1 with a LAN mask, a 24-bit mask, which is pretty typical. So I didn't need to actually uncomment any of these, but these are the settings that are going to be used. We'll go to our WAN section. Likewise, we also need to set our WAN interface. That will be ETH2. We're running PPPoE on our device. We have our username and password for the PPPoE connection that the device is configured to send in order to establish a connection with CDRouter on the WAN. So these are the settings that our device is configured for. In addition to, so that's our basic setup for the LAN and WAN. We enable TR-069 by going in here and uncommenting the ACS IP test var. And this enables the ACS on CDRouter, and it will use this address by default. You can change this to any address, any remote address that you want, so long as it's not used by the WAN or LAN connection or any other test var section that might be defined in your config. By default, the ACS runs on port 80 using HTTP. You can modify these test vars to either change the port number, or you can change to HTTPS and use a different set of authentication algorithms. The ACS default user and default password are the credentials that the device should be configured with in order to connect to the ACS. So you'll want to update your device or change these test vars to match what your device is going to use to connect to the ACS. And the CPE default user and password are the default values used by the ACS to connect to the device unless the ACS reports a different connection request URL. And if you're going to be using SSL, then you'll want to possibly look at this section. By default, we use a VeriSign signed certificate. The ACS uses a certificate signed by VeriSign that should be accepted by the device, but if you have a separate set of certificates, you can supply them here and uncomment the ACS cert path and CA cert path. Okay, so that's our basic configuration. We'll give this a config name. We'll check our config. And then we save our configuration file. Now we're going to create a package to use this configuration. This will define which tests we run, which configuration file is going to be used by the test run, and whether we want to repeat any tests or alter the execution in any way. Select our configuration file here. This is the one we just created. We'll use the default options here, so we're not going to repeat any tests or pause. We'll go down to the CDRouter TR-069 section, expand this. Let's select a test from here, from the TR-069 section. And we'll go down and we'll select our CWMP scenarios test. And make sure that this test is selected. This will execute all the defined scenarios or a single test scenario. So if we launch our test, this test will run. I'm going to jump over to the results. What this will produce with the default config file is we'll have we'll have results that look like this, where the CWMP scenario test was skipped. And if we show our skip reasons, we can find out why. And it's saying that no CWMP scenarios have been defined, and it's going to skip. You can also click on this to get more details about what the reason for being skipped is, and instructions on how you might be able to correct this. It has a link to the documentation that will explain how the CWMP scenarios tests operate, and covers all of the full documentation for the feature. In this case, what we need to do is we need to make sure that in order to run the CWMP scenarios test, we need to have this test file, CWMP scenario path, defined. This is the pointer to the scenarios file that we need to create. So we'll go back to our config. That means we'll need to go back to our config and define this. So we search for scenario, we find this test var here, we're going to uncomment it. And we need to give it the path to our scenarios file. But first, before we have that, we need to actually create a scenarios file. So previously I showed you an example of a scenarios file, so I do have some scenarios files predefined here. And let's look at the CWMP scenarios NTP is the one that I stepped through with you guys here. So this contains all the definitions that we covered previously. So we are going to update our test var with the path to that file. Check the config, save it. We can go back to our package and rerun it. So now when we run this test, we'll get results that look like this. Now our test is run, and if we go into the test log for the CWMP scenarios 1 test case, I have my filter set to log only, so I hide all the details and packets that went on during the test. And we can see just at a high level what happens here. So it begins by starting, it reads in the scenario file, and the first and the only scenario defined in the file is our NTP settings scenario. It tells me it's starting that, and then it hits the first command in the scenario, which is the get parameter names. The get parameters names, as we recall, verified the writable status for each of the writable attribute for each of these parameters. So we see that it's making that verification that each of these is set to false or true as was specified in the file. Continues to get parameter values and verifies the value of the first server, and the second server is null, and current local time exists, but it doesn't verify what value it had. It doesn't care about the value. It performs set parameter value to change the NTP server to pool.ntp.org, and reports that the status was 0, which is successful. Then it performed another one, get parameter values to retrieve the new value and verify that the set was successfully, or that the value was successfully changed. So since each of these verifications passed, the entire test is marked passed. So here, this file creates a new scenario called port map example. It retrieves all the port map entries that might exist on the device currently. It adds a new port map entry, and it uses this instance directive. So when you say instance and then you give it a name, this instance 1 identifier can be used in subsequent requests to identify the instance that got created by the device when you did the add object request. So after the add object is completed, we perform get parameter values on the new instance, and we verify that each of the parameters within this instance has the expected default value. This particular device provides these default values for each of these parameters. So I've put these in. This is something I went ahead, I know what my expected values are, and I'm just putting in verifications for them in my test. Once I verify those, I'm going to change some of the parameters to create my port mapping. So my remote host is going to be 98.76.54.32. External port of 5000 maps to an internal port of 5000 for the UDP protocol, and those incoming connections will get mapped to this host on the LAN, 192.168.1.100, and then I've set my description text here. Then I verify, once the set has been performed, I verify that these values are returned on a subsequent get parameter values request. Once that's successful, I do another set parameter values on the port mapping enabled, and I set it to true to enable the mapping. And I verify that it is actually enabled. Once that's all completed, I delete the instance. Just like before, you can see how each of these steps is explained in the log file. It's beginning the port map example and goes through each of the steps. One thing I didn't cover here that I'll just highlight real quickly, in the set parameter values command, you can also, by default, you will set a value and the ACS just assumes that it's going to be successful. You can also supply the fault code keyword with the actual value of the fault code that you would expect from the device. So you can do some negative testing to try to set a parameter to an invalid value or set a parameter that doesn't exist and so forth. And you would expect the device to respond with a fault code, and you can perform that verification using that. Now, by default, I mentioned that you can define multiple scenarios in a single file. And so what will happen when you do that, if we were to take the two scenarios that we've just been looking at, the NTP settings and the port mapping, and put them into a single file, like I've done here in this CWMP scenario combined file. This is basically just the two files put together. So this, at the NTP settings one ends here, then we go on and we define a new one. And in our results, CDRouter by default will just run both of those scenarios all at once. So it begins and it runs the NTP settings, and once that one's done, it does the port map one, all in one test. Alternatively, if you don't want to run all of the scenarios in a single test, you can separate them out. There's two steps to this. Actually, the first step is changing your config file and setting the CWMP scenarios single mode test file. By default, this is set to no, which means it will run all scenarios all at once in the same test, like I just showed. If you change this to yes, then it will only run one scenario at a time each time this test is executed. So by default, each test in your package is only going to be run once. But if you change your package settings and to repeat tests a number of times, or to loop the package a number of times, then each time the test is executed, so here we have CWMP scenario 1 being run twice. Each time the test is executed, a different scenario will be run. It'll just move on to the next one. So in this case, we have the NTP settings. That's the only one that's getting run. We go back, we go to the second iteration, and this time it runs the port map example. And then finally, I'll just show you quickly an example of the reboot commands and open and close commands being used. I've modified my NTP settings scenario. We perform a get parameter values and verify the current value of the NTP server 1. We change its value, and then before we verify, we reboot the device. So we issue the reboot RPC to the device, and then we issue the close command. So get parameter values, we set the parameter, then all we just do is say reboot, and we close the connection. This closes the CWP session, the device reboots, and then the next request that goes out is a get parameter values. Now I don't need to explicitly open the session because after the reboot, the device is going to automatically initiate a session with the ACS, and this get parameter values will be sent during that session. Then after the get parameter values, I'm going to close the connection and open a new one and perform another get parameter values. So if we go back to our results, here's where we reboot. We close the connection, then we do the get parameter values. And during this time, all this yellow warnings is from where the device was still, has not come back up yet. And so the connection requests expire. But eventually the device does come up and initiates a session, and we perform our get parameter values request, and it succeeds. We verify the value. Here's the close command and the open command to open a new session. And we do another get parameter values. And then we end the test. And hopefully you've been able to follow through on this. If there's any questions, please let me know. We can